So we look at lines of symmetry. So if you look in our first diagram, the first one on the left, then we can see that we've got a line drawn up the middle. It's called a line of symmetry because if we use the line as a folding line and we fold the left side over, it will lie exactly on the right hand side. So it looks as though you've simply cut one piece off, but it's actually not been cut off, it's been folded, and if it's symmetrical it will lie identically over the other side. Again, if we put a mirror line in, then the reflection will give us the shape that we started with over here. So you can reflect a line and see what's called its mirror image on the other side. Of course you can reflect from left to right, or you can reflect from right to left. So that's the properties of a line of symmetry. So here are two shapes that have two lines of symmetry. One that is a vertical line and the other is a horizontal line. And if we folded the shape from left to right or from top to bottom, our half would match exactly the half below it, or to the left or to the right. So my first shape here has two lines of symmetry, as does my second shape. So my second shape, if we look at the left hand side, if it were folded over this vertical line, then this point here would go over to there, and it's called its image point. This point here, its image point would be here, and this point here, and so on. And notice that the distance to the line of symmetry and out the other side is exactly the same. So from this left hand top corner to the symmetry line, exactly the same distance from the right hand top corner to the symmetry line. And notice again that the line forms a right angle with the line of symmetry. Now that's the vertical line of symmetry. This particular shape would also have a horizontal line of symmetry through the middle of the shape. So our image point top left would, through the horizontal line, will now be bottom left. And the distance from here to here is exactly the same as from the symmetry line up to the top. And although you can't see the line, I'll just take a pen and draw it lightly in. If we draw a line of symmetry, got the pen now, I think I've got the wrong colour on it, hang on. Okay, so here's the line coming down, and you'll see that it forms that right angle there. We don't need to draw that line, but just to show you the properties of symmetry, you'll see that the line that goes from, say this is A, to its image A dash, must form a right angle with the line of symmetry that you're looking at. Okay, so that's lines of symmetry, two shapes with two lines of symmetry. We'll have a look next at something that's got more lines. We'll now look at lines of symmetry through regular shapes. Now if we look at the two diagrams, the first one is an equilateral triangle. So it has three sides, and each side is the same length, and each angle is the same. Each in what's called the internal angle, the angle between the two sides on the inside. So the number of lines of symmetry matches the number of sides of the shape, and you can see that this one's got 1, 2, 3. Don't get confused and count 6, because if you count this one and that one as separate, you're actually referring to the same line, just from a different position. So you've got 1, 2, 3 lines of symmetry in the triangle, and that matches the number of sides. And here we're on a 7-sided shape, and there's 1, 2, 3, 4, 5, 6, 7 lines of symmetry in this regular shape. The regular shape, all the side lengths are the same, and the internal angles are all the same. So really the rule is quite simple. The number of lines of symmetry matches the number of sides in any regular shape.